my PhD work under theme 7, which is on DER participation in wholesale electricity market, utilizing TSO-DSO coordination. So here are the contents of my presentation. Initially, I'll discuss about motivation and then about the coordinated market operations framework that we have proposed in our work. Coming to the motivation that has led to study this work is the increased penetration of DERs, definitely, which have transformed passive distribution networks into proactive players in the electricity market. For managing these resources in the electricity market, there is an emergence of DSOs that are acting as an aggregator and taking charge of the dispatch of all DERs within a distribution network. So in this respect, if we are having multiple DSOs in our network, and for every distribution system, and they all are having their individual local objectives and providing their local dispatches, then in that case there could be a possibility that we have a lack of system-wide cooperation, and there could be conflict within the objective of DSOs and TSO. So in this regard, to improve the overall efficiency and reliability of entire power system, it is important that TSO should coordinate with all the DSOs to achieve certain social objectives. Thus, we need to facilitate exchange of power flows and control signals at the bus of common connection among TSO and GSOs. The integration of DERs that has led us to design an energy market framework utilizing TSO-DSO coordination. What all we need to focus upon is we have to make an optimal and effective utilization of all the resources available in distribution system. We need to define the role of different entities involved in this market framework. We need to analyze the overall benefits derived from this framework, and then to study various possible ways of communication between TSO and GSO. As per now, many countries have explored different options for practical implementation of TSO and DSO coordination. There are 5 different schemes which are widely discussed across the globe. These are like TSO model, in which TSO is the leader and they are directly interacting with DERs, but having no control over congestion management taking place in distribution network. Other one could be DSO-led model, in which DSO are managing the local congestion and transferring the unused resources to transmission system. The next could be TSO-DSO hybrid model, in which TSO is managing congestion and balancing and transmission level, while DSO is managing congestion and balancing at the distribution level. Fourth one could be common TSO-DSO model, in which TSO and DSO together are managing these services with certain coordination with each other. And fifth could be a third-party model, in which TSO and DSO are procuring ancillary services from a market operated by a third operator. So in our studies and in our work, we have focused upon the fourth type of model, common TSO-DSO model, in which TSO and DSO together taking care of balancing and congestion services and clearing the markets. So here comes the proposed market framework. The typical integrated power system could look like this, in which we are having a transmission system having directly connected generating units and consumers, and then we can have a distribution system in which we can have multiple type of DERs like wind power sources, energy storage devices, DG, solar power aggregator, flexible consumers, which could be equivalently represented as a generating unit and a load unit. They are interacting with their respective DSOs, and transmission system entities are interacting directly with the TSOs. Then later we can have a communication between TSOs and DSOs as well, and the flow of power and data flow could possibly be represented as shown in this figure. We'll see the type of interaction that could be there between TSOs and DSO is like TSOs taking control of their own aggregators and DERs and concentrating on its own objective function. Similarly, TSO can have control over its own consumers and generators, and what we need to facilitate is the exchange of information such as price and power between transmission and distribution system. So these are the publications that we have come that are under revision based on this work. So today I'm going to present work which is represented in the second publication. Now coming to the market, possible types of coordinated markets. So in the broader view, we can say there could be possibly 2 types of coordinated markets. One could be real power markets, or we can say energy markets. Other one could be real power plus reserves market. Then in both of the types of market, we can have day ahead and real time, both market frameworks. Uh, Presently, we are focusing upon day ahead energy markets. In that also, we can have two types of possible market architectures based on the direction of power flow. So, or based on the quantities being traded or bid or offered. So, DSO could act as an importer, and where they're offering only the demand quantity bid, or DSO can act as an importer plus exporter, in which they are offering the quantity price supply bid and quantity demand bid both. So in this work, we are primarily focusing on the second part, where DSO has the potential capability, flexibility to import and as well as export the power, in at least in terms of trading, if not physically, but in terms of trading. This is the illustration of the power system that we have considered in our work. In this, we are having a transmission system to which we have considered directly connected entities as generating unit, constant loads, and some flexible loads, and other are the DSOs. So DSOs, we can have two types of distribution system. Type A type of distribution system, they are supposed communicating only demand bit quantity, while in the type B distribution systems, they are communicating demand bits as well as the generation offers and the corresponding prices for which at which they are offering their power. And further, in these type of distribution systems, we can have further two types of DGs. Here we are considering DERs, DGs particularly in the category of DER. So I can have a DG which are offering their generation both in wholesale market and in the local market, or there could be DGs which are participating only in the local market. So it is purely a wish of a DG operator in which market they want to participate. So if suppose a DG can participate like a gamma percentage of its total capacity in the wholesale market and the remaining in the local market. In this whole scenario, the roles of DSO would be like this, like both the types of DSOs who are operating their individual their respective local markets, they are taking a price which is being given by a transmission system operator at the boundary buses, that is a coupling buses, a pi naught, and they have to take that price. And then the DSO has responsibility to aggregate the quantum and price of power to be offered and the quantum of power to be purchased from wholesale market. Then DSO has to evaluate the share of each DER and their associated prices plus incentives. And also DSO schedules demand for its flexible loads. And while it is a choice of a DER owner whether they want to participate in local market or wholesale market, and how much percentage of their total capacity they want to offer for each market. So this could be a sort of a timeline diagram or a coordination structure of a coordination scheme, where initially all the DERs, they are providing their demand bids and generation offers for both types of market, and a DSO, while clearing the local market, considers these bids and the price signal, which is derived probably from the past historical data, and then they clear their market, and then they further provide the total demand to be purchased from wholesale market and the total net generation offers they want to make in the wholesale market. Then the wholesale market gets cleared, taking the external bids and offers from directly connected entities and from the DSOs, bids and offers from DSOs. And then after getting this market cleared, we can have the final dispatches and prices of those other external entities and for all the DSOs. Now again, a DSO will get a chance to clear its local market with the updated DG offers. Suppose a DG is not getting selected in the wholesale market, so now again an opportunity is being given to a DG owner to participate that remaining or unused quantity into the local market. And now DSO has a better indication of the price at the boundary basis, so they can do their scheduling and dispatches more optimally. And finally, we can have the load and generation dispatches, and then later DSO can make the financial settlement. So the idea of this whole scheme is to motivate DERs to participate in wholesale market, probably for two reasons. Maybe there could be an improvement in the social welfare for a distribution system operator, and those type 1 DGs could be incentivized for making their participation in the wholesale market. And here comes the mathematics and behind these models. So we have formulated these two market models, TSO and DSO market model separately, where each of the market model output depends upon the input received from the market clearing of the other model. So here TSO is, suppose while clearing the TSO problem, our objective function is to maximize the social welfare, and I am consider the third term in this objective function represents the offers received by the DERs, and this is kind of an input from DSO markets or from the DSO, and subject to the various constraints on each entity. And this market model is being formulated as a loss compensated DC OPF model, taking to consider the impact of losses in the transmission network. And secondly, DSO market clearing model, in this again objective function is to maximize the social welfare, and here second term denotes the amount, the price to be paid for purchasing the power from the wholesale market, and again subject to variety of various constraints. And this model has been formulated as a second order conic programming formulation, and these all constraints takes care of the power being scheduled in the wholesale market level also while clearing the local market, so that congestion management could be done properly, effectively. Next, coming to the settlement of type 1 DGs. Now, DGs who are participating in wholesale market, how they can be paid, so that they have the option to get an incentive and they are motivated to participate in wholesale markets. So for this, for the understanding point of view, we let there be two units of type 1 DGs, DG1 and DG2 in a distribution systems, and they are offering their quantities P1 and P2 at a price of beta 1 and beta 2. Such as beta 1 is lesser than beta 1, first unit is a cheaper unit and second one is an expensive unit, and the LMP at the boundary bus received is suppose pi naught, which is being definitely set by the higher price units. So there can be multiple scenarios, like both of the DGs are not getting cleared in wholesale market, or first DG is partially or fully cleared and second one is not cleared because it is an expensive one, and first is fully cleared and second one is partially or fully cleared. So in these all the scenarios, what matters is how we are how a DSO is paying these DGs the surplus amount. If suppose they are paying as a pay as bid using pay as bid method, so they are being paid as at the price being offered. But what about the remaining surplus amount? How it can be distributed among those DGs? So there could be a fair enough situation. So there could be possibly like 5 methods for distributing that surplus. It can be distributed equally among both the DGs, or in secondly as in proportion to a pay as bid payment, thirdly in proportion to their offered prices, fourth one could be like distribute the surplus can be distributed in proportion to LMPs in the local market, obtained in local market, or as in proportion to the weighted sum of LMPs. So we have tried to formulate what could be the possible ways of distributing the surplus and which could be the better one. For this analysis, we have just considered a small system in which IEEE 14 bus system is representing a transmission system, and we have connected 17 node distribution systems at 3 buses. So 10, 11, like we are having distribution system 1, 2, and 3. First distribution system is a type A distribution system, which is only providing a demand bit to the wholesale market, while second and third are type B type of distribution systems in which they are offering both things. So every distribution systems are further having multiple DGs connected in their network, and here we have considered like 2 DGs are type 1 DGs and 2 DGs are type 2, like who are only participating in local markets, and 2 are participating in both. So here the point to be noted is like we have considered this fourth DG to be the fourth DG in distribution 3 to be like bit more expensive, so that we can analyze the economics going around this particular DG. And then again we have considered 3 time intervals representing off-peak load, medium peak load, and peak load periods across a day. to check the effectiveness of this proposed methodology. So we can see when at t equal to this, so this figure represents the inputs and outputs at various stages of this market clearing procedures. So seeing the final outputs of the local energy market, if we will focus on this particular table, then at t equal to 4, when we are having an off-peak load, then the most expensive unit, that is DG4 in distribution system 3, is not getting scheduled in any of the market because we are having an off-peak load. So at the same time, if I'm going to a medium peak load duration, in this whole capacity is being absorbed in the local market and it is not getting cleared in wholesale electricity market because it may become cheaper and our objective function is not getting maximized. While if we'll move to the peak load period, then we can see this quantity is being scheduled, the desired quantity is being scheduled in the wholesale market as well as in the local market. So doing all these things, coming to the comparison scales, firstly we can see the social welfare of the distribution system operators. So in case A, we have considered the type 1 DGs are participating in both markets, and in case B, type 1 DGs are participating only the local market when they are not giving the option to participate at the wholesale level. So we can observe note a significant improvement in the social welfare of distribution system operators. And in case 3, we will see at t equal to 19, there is a noteworthy improvement in the social welfare of a distribution system operator when they are participating in wholesale market at a peak load period. Next, coming to the incentives to type 1 DGs, so where incentives are calculated for both DGs in each distribution system for using different methods, and it can be observed from this. Method 3 is more suitable for distributing the this incentives among the DERs, because in method 3 we are using the distribution on the basis of the prices offered. So here the incentive for DG4 is higher, which is actually offering a higher prices in the wholesale market, and that is the major player in setting up a higher market clearing price as well. So method 3 could be a probable good one to decide to distribute the incentives to the type 1 DGs. And this is all from my side. Thank you. And you can, for any question or concern or suggestion, please contact at this email ID, or I can take up questions now as well. Thank you.
Thanks, Megha. There's already a question in any comment on the timeline, information, and clearing with respect to DSO, TSO, and the local market?
It's just that whenever we are scheduling to operate our local market in the distribution system, there are just one or two steps ahead that. So it's all about fitting. Suppose it's a 1 hour interval market in a day ahead. So it's all about at what time you want to fit in this structure. So it is independent. It is completely up to the system operators how they are setting up on that timelines.
Okay, are there other questions?
Megha, I think nice presentation. I have just 1 or 2 comments actually. So you are assuming that the market on distribution side will be run by DSO, or will there be any separate entity?
Sir, I am assuming it to be a DSO, but as like we are having different models, like in Europe it is different and in US it is different. So whatever is the current scenario in any specific country, they can have a separate market operators as well. But in our model, it would be preferred if we are having the same DSO as a system and market operator both, so that they can easily take care of all the network constraints and the trading challenges.
Yeah, so then just imagine there are 3 different entities on transmission side. One is which is running the power exchange, second is the system operator, third is the network owner. And right. Similarly on distribution side, if DSO is running market, then one entity, and second is the network provider, DISCOMs. So yeah. Now how whole coordination will take place? Like different entities also have to come into picture, not only TSO, DSO.
Yes, yes, sir. That's why I mentioned earlier, like if the system and market operator both are the same one, then this could be a possible, like
Yeah,
more
then it is
easier
easy.
way.
But you are
Then
also
it is
assuming
easy.
TSO is owning the, oh, you are saying transmission system operator, not ISO. So you are assuming that they are the also network provider.
Yes, but sir, if it is like separate entities involved, then it's like there will be more steps introduced in between in which communication has to take place. So it may create little bit of, or it may take a more a broader time window, or it could be like a delayed process. So in real time, there will be more challenges to implement this scheme.
Okay, and your settlement model is for the energy procurement. But quite relevant thing will be the flexibility procurement, flexible power from
Right,
TSO side. Yeah,
right,
so
sir.
that,
My next task is to address the flexibility issues only, and like I'm working on the flexibility challenges. This work was for energy market only.
okay, good, good. Yeah, that was the confusion. Yeah,
Yeah.
very good.
Thank you, sir.
All right, do we have any other questions? Okay. Thanks, Megha, for that. Appreciate your presentation. All right.
Thank you so much, ma'am.